For some, BBSs are a forgotten peculiarity lost in the trash bin of history. For us, though, they were the technological and cultural gateways that took us into the connected era. So today on the Serial Port, we're heading back to the past to recreate a 90s era BBS, running on none other than OS2 Warp. Our goal is to set up a multi-node BBS complete with both dial-in and telnet capability. So come join us as we head back to the 90s and relive the BBS dream. But was it really a dream to run a BBS? While there were undoubtedly positives, it could also be a frustrating, annoying experience that would turn many would-be sysops away. From dealing with misbehaving users, hardware failures, and software configuration nightmares, the actual experience of running a BBS was often fraught with problem after problem. A common hobbyist BBS setup in the early 90s was using a PC and DOS-based BBS software. There were many BBS software options to pick from, and once you got the BBS up and running, the computer would effectively be dedicated to running the BBS, as DOS did not support true multitasking. Perhaps this would have worked fine if you had a spare older PC to run the BBS on, but what if you wanted to use the computer while the BBS was running, to do other tasks, or even to log into the BBS yourself and keep improving it? If the BBS was popular and you had the funds, you might want to add additional nodes to let more than one user at a time call in to the BBS. By offering multiple nodes, you could open up a whole new experience for users. Whereas most users were used to exploring the world of a BBS by themselves, logging on to a multi-node, also called multi-line BBS, was many users' first real taste of the true interactivity on a connected medium. Prior to Windows 95, there was an operating system that did allow for multitasking with DOS applications, and that was IBM's OS2. While OS2 started off as a partnership between Microsoft and IBM, the partnership crumbled and OS2 became exclusive to IBM, while Microsoft focused on the Windows family. First released all the way back in 1987, OS2 evolved over the years until maturing into a product called OS2 Warp. The last version, OS2 Warp 4, was released in 1996, but development continued into 2001. OS2's true DOS multitasking originated in version 2.0, allowing multiple DOS virtual machines to run concurrently. And to be fair, there were third-party options for DOS like Desk View, which allowed multiple programs to run simultaneously. And there was rudimentary multitasking support in Windows 3.1 Enhanced mode, but OS2 was the obvious choice for any serious sysop needing to run a multi-node BBS back in the 90s, due to its native and robust support for a wide range of DOS and Windows programs that could all be multitasked. So we've chosen OS2 Warp 3 as our operating system of choice. It has better hardware support and networking over the version 2.1 predecessor. Coupled with the fact that it was released in 1994, roughly around the peak of BBSing, it's the perfect candidate for our project. And to keep it in the IBM family, we're installing it on an IBM Aptiva. This particular model is the Aptiva A14 Type 2144, which was originally released in 1995. It packs a Pentium overdrive processor along with 96 megabytes of RAM. We're using an external modem along with an ISA NIC that we've installed for LAN connectivity to the BBS. With that done, let's get started on our OS2 Warp 3 installation. Now that we have OS2 Warp installed, we're reminded of how cutting edge it was back in 1994. The GUI was enhanced with its workplace shell, and it included built-in support for the internet, which you wouldn't have had in Windows 3.1 at the time. Fortunately, our Warp install recognized our Intel Ether Express LAN card, and with some basic configuration, we're able to ping host on our LAN and use FTP to start downloading files to the system. Our BBS software of choice is Renegade, a popular DOS-based BBS package from the 1990s, one we both spent countless hours tinkering with and modding back then. The first requirement for Renegade is to set up something called a fossil driver. We do remember setting these up in the 90s, but we wanted to better understand exactly what a fossil driver is. Created in 1986 by collaborating developers Tom Jennings, Win Wagner, and Tom Henderson, Fossil stands for Fido Opus CDOG Standard Interface Layer. It was named after their respective software packages: Jennings' Fido BBS, Wagner's Opus BBS, and Henderson's CDOG Mailer. One of the problems early on was that there was no standard communication port software that worked across different personal computer platforms. Their Fossil driver, however, established a standardized way of accessing various UART devices, preventing the need to write custom code for each type of UART. A notable early success was running Henderson's CDOG Mailer on a DEC Rainbow. And among the popular DOS Fossil drivers from this era were David Nugent's BNU and Ray Gwynn's XOO. So while DOS had excellent Fossil driver support, OS2 version 2.0 released in 1992 had a major limitation. Its serial drivers were limited to 9600 bits per second, while US Robotics had already brought a 14.4K modem to market in 1991. Ray Gwynn leveraged his work with XOO as well as decades of experience with serial communications going back to the 1960s for the OS2 market. He developed an OS2 serial driver with Fossil support called SIO that supported bit rates up to 115.2K. It became the preferred serial driver for many OS2 users, and was even recommended by IBM's own support, as some DOS and Windows applications that didn't work with IBM's built-in driver would work with SIO. While dial-up BBS sysops were flocking to SIO, Gwynn also saw the growing importance of the internet, even though he described its primitive state as being unfriendly. In response, he developed vModem to connect TCP/IP to serial interfaces, and vModem was packaged with SIO starting in 1994. It integrated neatly with SIO, enabling BBSs to be telnet accessible over the internet, as well as some additional features in a new vModem protocol. SIO version 1.60D was widely recommended, so we opted for that version. As typical of software at the time, it was distributed with a free trial license, but registration and payment was required to unlock speeds above 38400 and to use the software perpetually. So, we filled out the order form to register the software with support for 4 ports. After mailing in the order form and a check, we proceeded with trying to get it working while we waited for our registration code. After unzipping the distribution file, we run install.exe, which copies the files to a directory and adds the device drivers into config.sys. And after a reboot, we can see SIO recognizes our COM ports in the boot sequence. We can see it detected the physical COM ports on the system, but we want to go ahead and set up a virtual COM port for Telnet. So we're adding this to config.sys and rebooting again. And now we can see COM4 should be working as a virtual COM port for Telnet. As we said earlier, we plan to use Renegade as our BBS. It was a fork of Teleguard, which was itself based on World War IV, originally released all the way back in 1984. But Renegade was written in Turbo Pascal in the early 90s by Cot Lang. It's still actively developed to this day, an effort led by TJ McMillan, sysop of the Titanic BBS. Let us know in the comments if you want to see a deeper dive into Renegade history, as there is quite a lot to its story. The latest version of Renegade is 1.33, but we had some issues getting the serial ports working, so we went back to a much older version. Renegade's version numbers have traditionally been very confusing. Back in the 90s, we used version 05-11, which was released May 11th of 1996. But those old versions weren't year 2000 compliant, so we decided to try the Y2K Alpha 2 release by Jeff Herrings, which is what the Dark Realms BBS runs on today. However, Y2K-A2 was only released as an upgrade, so we needed to first install an older version, 99-044, which is from 1999, day 44. After the quick install process, we looked through some of the configuration and confirmed local logon was working. We then moved to unzipping the upgrade archive and followed the README for upgrade instructions, which were pretty simple. We needed to copy over 2 new files, run an update program, and then delete the multinode.dat file. From there, we launched the new executable, and following Herring's instructions, hope like hell it works. After launching Renegade in local mode, we can see the Y2K-A2 version number displayed when logging in, so it looks like the upgrade worked. So now we need to turn our attention to OS2. While OS2's DOS support was fantastic, it does require some manual configuration to get the best performance out of it. But luckily, we can consult full os2.txt. It's a 10-step guide to setting up a DOS-based BBS under OS2, and it was written by Tony Harrison in 1995. It walks us through creating a new folder for our BBS command prompts and creating the DOS launchers with customized DOS settings. An important step here is enabling vxoo.sys in the DOS environment, which is what enables the fossil driver for DOS. From there, we update the rest of the settings with the recommended values. And now when we open a DOS window, we see that vxoo.sys is installed. So now let's try to get a modem working. After launching Renegade, we were greeted by a system error when trying to access COM1. So we pointed Renegade to COM2 and connected an external US Robotics Sportster modem. We made a batch file to automatically launch node 1, and we see the modem responds to ATZ with OK.
That's efficient.
Now we're cooking. We weren't as close to success as we thought though, as the screen would just flash when the modem's ring came in. After going through the settings again, we confirmed that we did have hardware flow control turned on and thought there must be some sort of configuration problem. We finally realized that our Sportster modem had auto answer enabled for our Portmaster ISP configuration, but that needed to be disabled so Renegade could send the ATA answer command. Not wanting to disrupt our critical ISP operations, we opted to swap in a multi-tech modem in its place. After plugging in the correct net string, we are now hearing the sweet harmony of a modem handshake. With that working, we decided to initially run the BBS with 3 nodes. Node 1 for a dial-in modem, Node 2 for Telnet, and Node 3 for local use. For Node 2, our Telnet node, we set the init string to just plain ATZ and COM port to 4. And once vModem is started, the virtual modem is initialized ready for Telnet connections. And when a Telnet connection comes in, we instantly see a connect message, but the wait for caller screen just reloads a second later. This was actually a common problem Renegade sysops had with vModem back in the 90s. And hilariously, we actually stumbled upon a simple workaround that Mark had posted to a Renegade news group all the way back in 1998. Who knew that a quarter of a century later, we'd be using it again? And the fix is just to add 2 tilde delay codes to the answer string. And now, Telnet login is working. Dialing in or now telnetting in is very powerful for the sysop or co-sysop, with all of the sysop functionality available. From a remote connection, we can manage the BBS, validate new users, and even drop to a DOS command shell. And after validating some new users, we can now see who's online and jump into teleconference to test out multi-user chat with 3 users, 1 dial-up, 1 telnet, and 1 local. And with that, our multi-node Renegade BBS running on OS2 Warp 3 is now set up and ready for callers. Getting the serial port BBS up and running has been a thrilling nostalgia rush for us, and the challenges along the way reminded us of how being a sysop can actually be a tough job. Now that we've got the hard part over with, we'll be customizing, modding, and maybe even adding additional nodes to the BBS over the next few months, and our Patreon members will be helping out with testing all of it along the way. We've got more BBS content coming in the future, so please subscribe if you haven't already. Thanks for watching, and we'll see you again next time.